So, hello students, hi everyone, very good morning to one and all. So, in this video, we are going to discuss our class 2 of M1 for our engineering students. So, without any delay, let's start. It is our class 2. Okay. Here in this video, I am going to cover chapter 1, unit 1. In unit 1, I am going to tell about you types of matrices. So, unit 1, matrices. In matrices, I am going to teach you about types of matrices, different types of matrices I am going to cover in this video. Okay. So, here we go. So, first of all, we have different kinds of matrices, students. So, our thing is like first, to start with the basic things, we have to know first what is matrix. Matrix is nothing but it is a representation of some elements in a rows and column forms or format, you can tell. We are representing some elements 1 2 3 4, let's say some m elements, okay, and some, okay, so total there are some m into n elements, let's say. That is, the order becomes m into n. That means there are m rows. You can see 1 2 3 4, like that. You have m number of rows and you have n number of columns. So the order becomes m into n, where order is nothing but it is the rows into columns, which gives total number of elements in the matrix. Elements in matrix. Okay. So this is all about your definition of a matrix. I am repeating once again, students. A matrix is nothing but a systematic representation of some elements in a format of rows and columns. That elements can be either numbers, alphabets, or whatever it is, variables, anything. So order is nothing but the total number of elements representation, that is rows into columns. That is here m rows and n columns, so m into n. Rows are nothing but the horizontal sections are rows, the vertical sections are columns. Okay, don't confuse here. Okay, now let's see about some basic types of matrices. Now, types of matrices. So, that the first one is row matrix. What is meant by row matrix? A row matrix is nothing but where number of columns is equal to 1. That means you have only one column and sorry students, there was a small mistake. It's not number of columns. Row matrix. What is row matrix? Row matrix is nothing but it has only one row in the matrix. That means there is only single row in the matrix. The columns can be anything. It can have n number of columns. Like you can have like some numbers, any numbers. You have many elements, so on. You have n number of columns. N number of columns in this row, but there is only one row. If you have m value, that means number of rows equal to 1, then you call it as row matrix. Okay. Generally this row matrix will have the order like this, like 1 into n. N is the number of columns. Similarly, you have your column matrix also. I hope it's visible and audible clearly. You have your column matrix where the number of columns obviously is equal to 1, similarly to this kind. But here you will get this one, like you have m number of rows, but you have only one column. Okay, you have only one column. That means your order will be m into 1, where n is equal to 1. You call it as column matrix. Got it? Let's say for example here, I'll give you one example. Let's say there is a matrix 1, 2, 3. So here the order is 1 into 3. So 1 row and 3 columns. It is representing only row, right? It is representing a row. In real time example, when can you list some such type of row matrices? Like now there is a bench. In a bench, how many students can sit? Like for example, there can sit person 1, person 2, person 3 for max, let's say 3 persons are sitting. So it represents a row, right? In that bench, all 3 members are sitting in 3 different columns, but they are in same row. So it's a row matrix. In the same way, when can you say it is a column matrix in real time? Column matrix is like you went to a car parking area. All the cars are in same column and they are parked along one by one. They don't have different rows. In the same line they will be get parking. So there you can observe n number of cars. Let's say some 5 cars are there. Car 1, car 2, car 3, car 4, car 5. So all these cars are in a column. So these are some particular examples. You can analyze what is row matrix and column matrix. So please take a screenshot of it. Then rectangular matrix. I think you can easily find out what is a rectangular matrix. Rectangular matrix. What do you mean by rectangular matrix? It is nothing but I can say number of rows and number of columns is not equal to 1, and you need not have a second condition. This condition is enough because it should not be column matrix or row matrix. It shouldn't be a column matrix or row matrix. That means to say you have a matrix like this. There is a matrix like this in which you have m number of rows and n number of columns. So m and n not equal to 1. If m is equal to 1, it becomes row matrix, which is not valid. If n is equal to 1, it becomes column matrix. Again, it's not valid. So it should not be equal to 1. Like for example, let's say you have some elements 1, 2, 3. That means there are few benches. There are 2 benches. In 2 benches, there are 3 people sitting, 1, 2, 3, and 4th person, 5th person, 6th person. So you have like whatever grid form only, like you have some grid form in graph, right? That grid form only you are representing in the form of rows and columns here, where you call this method as matrix method. So this matrix method, now there are 3 columns and 2 rows. 2 rows, row 1 and row 2. 3 columns, column 1, column 2 and column 3. So m into n, in place of m into n, I can write as m into n is nothing but 2 rows, 2 into 3 columns. So where m is equal to 2 and n is equal to 3, which both are not equal to 1. So it is a rectangular matrix. So this is a real life example and normal mathematical example. So I hope you understood what is a rectangular matrix. Take a screenshot of it. Let's go to what is square matrix. Okay. Square matrix. I hope you would understand by this time what is square matrix. It's nothing but m is equal to n. Should have a m is equal to n. Here in the previous slide we can tell here m not equal to n, because if m equal to n it becomes square matrix, but m not equal to n it becomes rectangular matrix. Got it? Square matrix is a type of rectangular matrix only. Okay, it's not a special kind. Let's say for example, same example, there are 3 students sitting in a bench and there are 3 benches. So here m is equal to n is equal to 3. So it's a square matrix. Got it? This is a real life example and a mathematical example. So you can have any kind of elements inside, but it is a square matrix where m and n equal to 0. Even 1 by 1 is also, you can call it as square matrix. Sir, you can tell this is a row matrix or a column. No. In row or column matrix, only one particular either row or column is 1. Here both are 1. So it's a square matrix. Both are equal. No, it's a square matrix. Okay. Please take a screenshot of it. Now let's see. What is a diagonal matrix? Let's see what is a diagonal matrix. First, what do you mean by diagonal matrix? A diagonal matrix is one in which only diagonal elements are present, remaining are zeros in that matrix. That is, now this is a matrix, let's say this 3 into 3, and a diagonal matrix should always be a square matrix. Condition is it should be a square matrix. In a square matrix only this is possible. In a square matrix only the diagonal elements, let's say 3 into 3, no? So these are, let's say 2, 5 and 7. The remaining elements, whatever are left over here, they should be 0. They should be 0. So these particular elements, the diagonal elements, are nothing but corresponds to your diagonal matrix. That means remaining element should be 0 and only diagonal element should be present. In mathematical form, you can represent this one as, let's see here. Now, Aij I will represent. What is my Aij? I represents your rows and J represents your column, row number and column number. If I tell A11, that is my first row, first column, this one. This is my A11. So this is my A12. First row, second column. This is my A13. First row, third column, and so on. Okay. Same way here, A21, A22, and so on. Then A31, and so on. So on like this. AM1, so on. Till here you will have like you will go on up to A1 comma n. That is m into n matrix, let's say. So you will go and you will have A, M and N. Okay. So that means A M into N element is the last element. That means if it is 3 by 3 matrix, A 3 3, that is third row and third column. This element is nothing but your M into N. So I hope it's understood. Now let's see here. Now if I want to say diagonal matrix is nothing but A I J is not equal to 0 for and Aij is equal to 0. I can tell the conditions like Aij is equal to 0 for I not equal to j. Sorry, I equal to j, right? Sorry. I equal to j. That means wherever the I is equal to j, all the diagonal matrix has I equal to j. The elements Aij are not equal to 0. They are not equal to 0. For I not equal to j, they are 0. That means I not equal to j, Aij will be 0 for diagonal matrix. Remaining elements are zeros. Okay. That means you may get matrix like this. Some k, let's say 0 0 0 0 so on. Then 0, some r, let's say 0 0 0 0 so on. Like this so on you will be getting some L, let's say. So only diagonal elements you will be getting. So this is all about your diagonal matrix. Please take a screenshot of it. Any doubts, please ask in the comment section. Okay. Next comes your scalar matrix. What do you mean by scalar matrix? Yes? What do you mean by scalar matrix? Before telling you the scalar matrix, I want to tell you about unit matrix. Okay? What is unit matrix? A unit matrix is nothing but where the diagonal elements are 1. That means it's a diagonal matrix where your Aij for I is equal to j is equal to 1 and Aij is equal to 0 for I not equal to j. That means you will be getting 1 1 1 1 so on, remaining are zeros, so on, zeros. You will get your zeros. Okay, all are zeros. So you will be having such kind of matrix. What is your scalar matrix is? एक मिनट आरो क्या हो ना ఏంటి చెప్పురా మీటింగ్ లో ఉన్నారా అరే డోర్ ఓపెన్ చేయలేను మీటింగ్ లో ఉన్నా ఒక 10 minutes ఆగలవా 10 minutes ఓకేనా hello. So your scalar matrix is nothing but Aij for I is equal to j is constant, is same for aij is equal to 0 where I not equal to j or 0. That means your scalar name is nothing but there is a k diagonal elements, remaining all are 0. The only difference between your unit matrix and scalar matrix is here you have constant value 1. It is also a type of scalar matrix, you can tell, where that k is equal to 1. So nothing but both are same, but only the constant value is fixed here, k equal to 1. Here it may be any k value, random k value, but it is same in the diagonal elements. Okay, so this is all about your this one. Now let's see. Please take a screenshot of it. I hope you understood. Next comes your triangular matrix, null matrix, and transpose matrix. Triangular matrix. You have two types of triangular matrix here. That is upper and lower. What do you mean by upper and lower? Let's see. Now, for upper triangular matrix, if there is a matrix, now let's say there are the diagonal elements K, R, L. Let's say it's a 3 by 3 matrix. Let's say K, R, L, and this part of triangle is my upper, right? And this is my lower. I can divide into two parts now, the lower and upper. In upper, I'll be having some values, like let's say some A, B, C. Okay, I'll be having some values, but all the remaining values are zeros. Okay, that means Aij is not equal to 0 for I less than j, or I less than or equal to j, and Aij is equal to 0 for I greater than j. I greater than j means here 2 is greater than 1, here 3 is greater than 1 and 2. So these columns where our row is greater than column, for there all the elements are zeros, but where row is less than or equal to column, the elements are not equal to 0. Same here is you get the K, R, L, let's say zeros you get in the uppermost, and in lowermost you get it as some values A, B, C, let's say. So same thing I can write Aij is equal to 0 for I greater than j, and I less than j, Aij not equals to 0. I less than j, that is I value is 1, 1, 1. See, 1 is less than 2 and 3 now. Here you can say that the elements are, sorry, I made a mistake. No, it's correct one. For I greater than j, the elements are not equal to 0. For I less than j, the elements are equal to, there is a small mistake here. For I less than j, the elements are equal to 0. Got it? I hope it's very clear to you. If you have any doubts, you can ask in the comment section. So please take a screenshot of it. Now here comes our null matrix. Null matrix. What do you mean by null matrix? Null matrix is nothing but all elements are 0, because there are no elements in this matrix. That means an m by n matrix whose elements are zeros will be getting zeros only. That means Aij is equal to 0 for all I comma j belongs to natural numbers. That means for any positive row or column, all the elements are zeros. Okay, very simple statement, null matrix. Then we will discuss about transpose matrix. Please take a screenshot of it. What do you mean by a transpose of a matrix? Transpose of a matrix. What do you mean by this? Transpose. Let's see. Transpose of a matrix is nothing but there is a matrix, let's say m by n, where rows are m and columns are n. So let's say for example A, B, C, D, E, F. These are, let's say this is my 2 into 3 matrix. Now transpose is denoted by A, B, C, D, E, F is denoted by this T or dash. It is denoted by dash or this. This is called transpose, where this is nothing but it is equals to my A, B, C and D, E, F. You can observe clearly here what has been changed. It is nothing but it is changed into 3 into 2, where my rows became 3, columns became 2. Here rows are 2, columns are 3, but here rows are 3, columns are. That means I have made this first row into first column and second row into second column. So columns and rows are interchanged or exchanged with first row with first column, second row with second column, like that. You are exchanging. That means simply you can say that I is exchanged with J. That you called as transpose of a matrix. So these are all your basic topics in your chapter 1. So I hope you are understanding all the points clearly and you are able to grasp, and please make a note of it also. It will be helpful in your further subjects, like further classes. I hope you don't forget all this, and if you want to recollect them in my further videos also, you can go back to my videos in the playlist of Engineering Max M1 and check this first video. This is a very basic. I hope you understand it well. And once again I am informing, like, this is all about to encourage BTech students, especially who are very weak in maths. That means many people are like almost, especially like 10 to 15 people are not getting this subject in BTech because most of the faculty, they don't concentrate over all the students. We have to read on our own. So reading books and following some YouTube channels like this will really help you. Not only my channel, whatever channel you feel it very understanding, you can please follow them. But in my channel, what is the specialty is, I am not teaching this in regular language, that is Hindi. Most of you people find a lot of videos in Hindi, but I am making these videos in English to help each and everyone who can understand English language but have a difficulty in Hindi language. Okay, if you want any further help, I can teach you in your regional language also, like Telugu and Hindi. I am well enough to teach this subject in Telugu, Hindi and English as well. You can ask any kind of doubts or personal approach also in the comment section. I will be very glad to approach you. And these are my videos. Please follow them, share it with your friends, like them, and comment it how did you feel, and any types of doubts also. Even you can WhatsApp me also. I will be approaching you, not an issue. And even I will be helpful for your home tuitions as well and online classes. Personally also I will be paying a platform for you as well in the future. So I will be helping you in all aspects. So don't worry of any cost. We will be doing a lot. Not only BTech students, even intermediate students also can grasp a lot of things after once you complete your intermediate education. These basics and all you can be well versed, because that will be helpful in your further classes. So once again I am telling, any kind of doubts you feel free to ask me. There is no nothing like if you have a doubt that someone will see you and you will be having some awkwardness. It's not thing. When you have doubt only, that means you are thinking of it and you are learning. We have to make mistakes and we have to learn from it. Okay, experiences are one which builds our platform well. Okay, and once again I am telling, this is my channel. It's all about maths, physics, chemistry, and this is especially for engineering videos. And I hope you would like this video. and subscribe my channel and click on bell icon for further videos. Thanking you. Signing off.